So carrying on from our last video where we looked at the product rule, we're now going to be looking at the quotient rule in differentiation. So if we have a fraction where we have one function of x on the top as the numerator and a denominator as another function of x, and we're differentiating this fraction with respect to x, we can use the quotient rule. So this is where we have the denominator by the differential of the numerator, then we subtract the numerator by the differential of the denominator, and then do all of this over the denominator squared. You'll be able to find this in some formula booklets when you're looking up tables of derivatives, and I'm just going to go through 3 examples now, which includes showing why tan x gives us sec x squared when we differentiate it. So that's quite an interesting one, and we'll show you why this all works. So first we're going to have ln x over 3x squared. So we're going to plug everything into our formula. So we have 3x squared, and ln x, we differentiate that, so we get 1 over x, then we subtract, and now we're going to differentiate now 3x squared, so that goes to 6x, and this is by our ln x, and then we do all of this, x squared all squared. Now we can simplify this. We can get rid of this term, get rid of our power there, and we can now get 3x minus 6x ln x all over 9x to the 4. Now we can divide both of these by, or top and bottoms by 3, so this goes to a 2, that goes to a 3, and we can get rid of 1 power here to get rid of that and that. And what we're going to find is we have 1 minus 2 ln x all over 3x cubed. And that's that. Now we do the second one, which is cosine of x over e to the 2x. So we'll try and write this one out a bit quicker. So we're first going to go and start by doing e to the 2x. Now the differential of cosine x is minus sine x, we put a minus here, sine x. We take away, now we have e to the 2x, we move our 2 down, so you have 2e to the 2x by cosine of x, and then this is all by e to 2x squared. Now you can see how you can simplify that yourself, sorting out squaring the bottom fraction, taking out the minus e's to the 2x, simplify the top, but I'm not going to go through that because it wastes a bit of time, but you can see how you simplify that yourself very easily. And finally we're just going to look at how we deal with tan of x. So we'll start by saying we know that tan of x is equal to sine x over cos x. So now we can use our quotient rule. So we have our cos x. Now we differentiate sine x, which gives us cos x. Then we have minus, and now we have our sine x term, and then we differentiate our cos x, which goes to minus sine x, and we make this now into a plus because we have minus minus, and we have all of this cos x squared. Now we simplify this a bit, and we have cos squared x plus sine squared x all over cos squared x. Now a mistake some people might try and make is by simplifying this here, simplifying that there, separating it into 2 fractions. Well, what you can do is just use your trigonometric identities and say that cos squared plus sine squared equals 1. We know that to be true, so we have 1 over cos squared x. This is equal to sec squared x. And you'll find if you do the differential of tan x, that's tan prime there, and you look at that in the table, you will find that you have sec squared x. And that's all for our videos on the quotient rule. We're now going to be moving on to some other stuff in differentiation. So if you want to see the last video or the next video, or you just want to see more from my channel, you can just go ahead and click here.